Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the second fundamental theorem, and I will give you some simple examples just to illustrate on the idea of this theorem. So let's say f is continuous on this interval a and b. Therefore, if you want to evaluate this integral of fx from point A to B, that can be easily found if you know the antiderivative, which is f. You know the antiderivative, which is the big F here. And if you know the antiderivative, which is big F, you can just evaluate that by subtracting the values of f at the endpoints. For example, you substitute b into the big F function, and then you will subtract that with the result of substituting a into the big F function. So that's the meaning of subtracting the values of f at the endpoints. And sometimes the process of this subtraction here can be represented by this notation. And although it is possible to use any antiderivative, but the practical choice would be to choose the most simple one. And notice that the integral can only be obtained provided that f is continuous on this interval. So this statement here is compulsory. It is important that you make sure that it is continuous on the interval a and b. So now I'm just going to illustrate some simple example based on the points that I have outlined on this slide. So let's say I have fx is equal to x. This is a simple function, and I want to find the integral of that from point 0 to 1. So in order to evaluate this integral according to the theorem here, I need to find what is big F. So now my choice would be I need to think about big F such that when I differentiate this, I will get back x. So it could be x squared over 2. Now when I differentiate this function here, so if I find the derivative of that, the derivative of this one can be found by, first of all, 1 over 2 is a constant. You can take it out. Then you differentiate x squared, you will get 2x. Based on this, you can cancel out 2. So you will be left with just x. And this is similar to this function here. So I can say that this is the antiderivative. Of course, based on the previous video, you have seen that you can have many options of antiderivative. For example, I can have gx equal to x squared over 2 plus 10. So when I differentiate this, I will also get the same result as this one. I can also have hx is equal to x squared over 2 plus 250. When I differentiate this, I will also get the same result here. So these two here are also possible options for antiderivative, but it is practical to choose the simplest one. So the simplest one would be this one. So the simplest one would be this one. So we will choose this one in order to evaluate the integral given here. So the simplest one is x squared over 2. So I'm going to write down this function. So x squared over 2. And I will represent the process using this notation. Evaluated at point B, 1 and 0. So this process is actually meaning that you are going to subtract the values of f at the endpoint. So this is the process represented by this notation. So I will just go on and substitute 1 into this function. That will be 1 over 2 minus, so minus 0 over 2. So you will get 1 over 2. All right. Okay. Right. Next. Well, I just have to stop the video. The baby is crying. So I will continue in the next video. Thanks for watching.